All right, we're back. We're on page 58, I guess, of math analysis, which is in note 6, which is inverse trig stuff, which I think is really cool. I like solving problems with inverse trig because a lot of nuances, a lot of things to think about, and generally speaking, when things are more complicated, I enjoy them more because they're more of a puzzle. You get to use your brain a little bit more. So let's see what we know so far. So this table has arcsine, arccosine, arctangent. We want the domain, the range, and the unit circle picture. I'm going to start with the unit circle picture because it basically tells you the domain and range. So here, for arcsine, I know that the unit circle picture is going to be solid dot, down here, solid dot, right? So what can I do there? I know that the y value, sine is y on the unit circle, the y values go from -1 to 1, so that's going to be the domain. So -1 to 1. Now the x and y thing can drive you insane, right? So arcsine, you take arcsine of the sine of something. Sine can be anything between -1 and 1 based on the unit circle picture. That's the y value on the unit circle picture. So those are the things you can plug into arcsine. The sine of anything. Ratios, do the inverse sine of a ratio. It gives you an angle, right? The y value is the sine ratio, and it goes from -1 to 1. The theta values are the range, right? And so theta in this picture of the unit circle, you don't go from, I don't know, like 3 pi over 2 to pi over 2. That doesn't make sense. You have to be continuous. So you're going to end at pi over 2. You start at negative pi over 2. So we get this. Once you understand how this little unit circle picture corresponds to the inverse functions, like you're set. You're going to fly through some problems. Inverse cosine is the top. So solid to here. So that's going to be 0 to pi are the angles. So that's the range. Now, cosine is the x-coordinate. X goes from -1 to 1 in this part of the unit circle. So you get this. So you can do the inverse cosine of anything between -1 and 1, and it will always give you something from quadrant 1 and 2 of the unit circle, and it'll be positive. You can do the inverse sine of anything between -1 and 1. It'll always give you something from quadrant 4 or 1 of the unit circle, but quadrant 4 is negative. It's not going to be a positive angle. It's going to be a negative angle. And then arctan, really similar to inverse, whoa, where are we going? Really similar to inverse sine, except it's open circle, open circle. I try to make those look pretty extreme. So we get this. So the angles, anything from negative pi over 2 to pi over 2, but you can't include them. So negative pi over 2 to pi over 2. And then the tangent value, you do the inverse tangent of anything. The range of normal tangent is all reals, so the domain of inverse tangent has to be all reals. So x is an element of the reals. So there we go. All right, so this is all information you have to have memorized. You just have to, right? So it's useful to know the unit circle picture. I use it all the time, but I also just have everything memorized. So make sure that you are doing that. All right, let's see if we can work out the graphs of these things. I am not super great at graphing them, but there's a lot of information that I want to make sure that I get on my graph. And so let's see if we can do this. We're going to start with sine. So let me just give you the lay of the land on this page because it's a little confusing. We are going to find up here, we're going to do everything for the one-to-one graph of sine. When we are done with that, we're basically going to take all the information we found and switch it and do the graph of arcsine. So up here is going to be one-to-one sine. It has to do with inverse sine, but like not really. Down here, all arcsine. So that's what's happening, because in class every year I get very confused because I like sometimes don't look at the notes ahead of time. I like to go in cold, you know, I like us all to be in the same place. So we are going to graph our one-to-one sine. So let me actually just like mention this here. One-to-one sine. All right, so I got to go up to 1. I'm going to go like here, I think. Now, I know that it's going to be between negative pi over 2 and pi over 2 because that's what we do, right? Quadrant 1 and 4. But it's really important to me that I be able to deal with pi over 6s. So I think what I'm going to, because sine of pi over 6 is 1/2. Like those are really good values. if you think sine and you're like, what's a good value? Pi over 6 should come to mind. If you think cosine, you're like, what's a good value? Pi over 3 should come to mind because the cosine of pi over 3 is 1/2. You do the like nice ones, right? So I'm going to say that this is pi over 6, 2 pi over 6, which is pi over 3, and then 3 pi over 6, which is pi over 2. And then I'll go the other way also. So negative pi over 6, negative pi over 3, and negative pi over 2. Okay, so this is actually a really good grid for graphing this, because I know the sine of pi over 6 is 1/2, and 1/2 is exactly between 0 and 1. So you get like some extra points that you can plot. Now it's tough. It's really hard to graph sine accurately when you have this many points. I don't really know why, it just is. So let's see if we can do it. So through the origin, it's like basically y equals x. The problem is, like, what does y equals x even mean on this? Because the x-axis is like pi over 6s. I struggled with this in some other video. It was like the graphing trig one, right? Where like I was counting boxes for slope, but I was not using the correct units. So that's not great. So let's see. I don't know, just kind of like go for it. It's gonna be like this maybe, and then like this. I mean, I don't know how you're doing a better job. I could do a better job on the left, maybe, perhaps. Let's see. Let me try again. So, like, you know what the problem is I really missed this one. I don't know. You know, it's good enough. I tried. I did my best. Not really, but I tried. All right, let's list some stuff here. Domain. Negative pi over 2 to pi over 2. Quadrant 4 and quadrant 1 of the unit circle. The range better be -1 to 1, otherwise things have gone awry. And then the 5 key points, right? So you got your quadrantals, those are always good. And for sine, you got your pi over 6s. So I'm going to say that my key points are negative pi over 2 gives me -1. Negative pi over 6 gives me -1/2. So why am I listing these? I am listing these because they give me a really good starting point for my graph of arcsine, because I know that I can just switch the x and y points and get points on arcsine. These are points on sine, so points on arcsine or inverse sine will be the reciprocals. Reciprocals? That is not correct. The what? The inverses, I guess? I regret even starting that sentence. All right, all of this has to do with the one-to-one graph of sine. Let's take this information and turn it into arcsine. We're gonna do our best. So the key thing here, domain corresponds to the range, so it's going to be -1 to 1. The range corresponds to the domain of the one-to-one function, but also just memorize it. And now here what I'm going to do is I'm basically taking these points and I'm swapping the x and y, right? So if negative pi over 2, -1 is on sine, then -1 negative pi over 2 is going to be on arcsine. The arcsine of -1 is negative pi over 2. Now we're starting to like use it. That's how it works. So here, -1/2 negative pi over 6. Hopefully you can see yours if you're handwriting it, so you like know these points. So the arcsine of -1/2 is negative pi over 6. 0, 0 is like the greatest point ever, because you know the arcsine of 0 is 0, the sine of 0 is 0, works really well. Then we'll get 1/2 pi over 6. The arcsine of 1/2 is pi over 6. And then we'll get 1 pi over 2. The arcsine of 1 is pi over 2. I keep saying arcsine. You can say inverse sine, same thing. Unit circle figure, which is the most useful part, is going to look like solid dot, go down, solid dot. Okay, so now, let's actually try to graph inverse sine. So this is going to be a graph of y equals sine inverse of x. So usually what I tell people is you don't shift this around. You don't like stretch it. You don't move it left and right. You don't reflect it really. You memorize this graph. You like see it, you memorize it, you'll be okay. So you're not going to like shift it around. So what do we have? We have -1, -1/2, 1/2, 1. So I think I should just count by 1/2s. on the x-axis. And I'm just going to do this. So negative 1/2, negative 1, 1/2, and 1. Okay. And then, all right. So on the y-axis, I got to basically do the same thing that I did on the x-axis to the graph up above. So I'm going to count by pi over 6s. So it's pi over 6, 2 pi over 6 is pi over 3, and then 3 pi over 6 is pi over 2. And then the same thing going this way. So negative pi over 6. I feel weird putting the tick marks on this side. Do I usually label on the left-hand side? Is there a convention for that? Probably. It's that you read from left to right. So I'm going to guess that I did that in a weird way. That's all right. All right, let's plot our points. Negative 1, negative pi over 2. The inverse sine of negative 1 is negative pi over 2. Negative 1/2, negative pi over 6. The inverse sine of negative 1/2 is negative pi over 6. 0, 0, best point ever. Inverse sine of 0 is 0. 1/2 pi over 6. The inverse sine of 1/2 is pi over 6. And then 1 comma pi over 2. The inverse sine of 1 is pi over 2. So those, you got to memorize those. You already know them though, right? Because you know the sine of negative pi over 2, the sine of negative pi over 6, sine of 0, sine of pi over 6, sine of pi over 2. You know those, which means you know these. You just have to like rearrange your brain again. That's what this is all about. So just keep kind of changing. So here, I don't know. Try to do your best. I'm like really bad at graphing these. So it goes like vertical at the end there though. And also that wasn't super great. So let me see if I can erase just a little bit of that and maybe do a better job. Let's see. I'm gonna pick up here. Try to. So there we go. I don't know. That's it. That's basically your graph of arcsine, right? So you're going to memorize that. 5 key points. Your 5 key points are, you don't have to necessarily label them on here, but it's a good idea. Negative 1, negative pi over 2. You get negative pi over 6, negative 1/2. You got 0, 0. You got 1/2 pi over 6. And then you got 1 comma pi over 2. So if you know those 5 key points, you know basically the only ones that you can ever do without like a calculator or some other way of working it out. So make sure you memorize those. Make sure you memorize the graph. The graph is increasing, which is like the only thing I ever really use it for, to know that it's increasing. Also, the shape of it, sort of roughly, is, so that's beautiful. Hold on, let's force lines out of some of this. So go away. All right, so what I was gonna say is that the shape of this is 1/2. I don't think I'm gonna be able to do this. It's 1/2 of an hourglass, right? So the hourglass, kind of like this, and then I'm like sticking, so that didn't work. But there's your hourglass. It's 1/2 of the hourglass. You know what the other half of the hourglass is? Arccosine. That's how I actually remember the shapes. Is I always think like, oh, it's the hourglass and arcsine is increasing, so it must be this part. And then I just kind of fill it in. Or arccosine, I'm like, oh, it's part of the hourglass, and arccosine, it turns out, is decreasing, which we'll see soon. So it must be this. So that's how I remember the shapes that I'm dealing with. But I'm going to actually delete this. So I hope you were watching when I did it. That'll give you a good idea of like sketching the shape. So I'm going to stop this here. I'll come back in the next video and keep going. So hope you're finding these useful. We're going to move on to arccosine, maybe arctangent. Who knows? See you there.